Linear programming. A linear programming problem consists of inequality constraints and an objective function. The goal is to find an optimal solution that satisfies all the constraints and maximizes or minimizes the objective function. The result of evaluating the objective function at an optimal solution is called an optimal value. The following is an example of what a linear programming problem might look like. A contracting firm is increasing its workforce. It wants to hire new surveyors and new project managers. Altogether, it needs to hire at least 50 new employees. Surveyors are paid an hourly wage of $22 and managers an hourly wage of $32. The firm does not want to exceed an hourly labor rate of $1,260 for the new hires, and company protocol says that there should be at least one manager for every 9 surveyors. The firm would like to keep the hourly cost as low as possible. To break this down, let's first identify what we want for our variables. Here, what we have control over is the question of how many new surveyors are hired and how many new project managers are hired. Now let's see if we can find some of our constraints. We can see that they want to hire at least 50 new employees. That means the number of surveyors plus the number of new managers should be at least 50. We also see that the firm does not want to exceed an hourly labor rate of $12.60 and that surveyors are paid an hourly wage of $22 and managers an hourly wage of $32. Whatever our hourly labor rate is, it should be less than or equal to $1,260. For every new surveyor hired, that surveyor will contribute $22 towards the hourly labor rate, and every new manager will contribute $32. Lastly, we see that there should be at least one manager for every 9 surveyors. This tells us that the ratio of surveyors to managers should be less than or equal to 9. To make this look a little bit more similar to our other ones, we can rearrange this to be number of surveyors should be less than or equal to 9 times the number of managers. And to make it even more familiar with how the others look, we could rearrange this to say the number of surveyors minus 9 times the number of managers is less than or equal to 0. Lastly, we should be able to identify what our objective function is. Our objective function should be the thing that we're trying to maximize or minimize. The keyword low as possible tells us that we're trying to minimize something, and what we're trying to minimize is the hourly labor cost. Because we've already calculated before what our hourly labor cost is, all we have to do is write it down again. And we should write down what we're trying to do with this. We want to minimize this. To find the optimal solutions and values, we're going to employ the use of the fundamental theorem of linear programming. The fundamental theorem of linear programming tells us 2 things. The first is that if the linear programming has optimal solutions, or has an optimal solution, then it will be one of the corners of its feasible region. The second thing it tells us is that if its associated feasible region is bounded, then there will always exist an optimal solution. These 2 properties will give us a way to solve linear programming problems.